Hello and welcome to SkillStack's YouTube channel. Today we are going to start a video series on basics of machine learning. In these videos, we will be covering Python packages like Numpy, Pandas, Matplotlib, Seaborn, and we will end with scikit-learn. In this and next couple of videos, we'll go through the basics of Numpy programming. So let's get started. Before we dive into Numpy, let's get some prerequisites ready. The first one is you should have Python or Anaconda installed. If you have Anaconda installed, that's better because you'll have all these packages which I have mentioned before. Those will be already installed. If not, you can install them manually. The next is you should have some basic understanding of how Python works. You should know basic concepts like loops, how we work with loops in Pythons, what are lists, what are tuples, what are dictionaries, and at the end, yeah, like I said, if you have a Python, if you just have Python installed, then you need a Jupyter notebook to be installed. But if you have Anaconda installed, then Jupyter will be already installed in your machine. Now, if you're not familiar with these things and need a refresher, you can check out one of my previous videos. I will add a link in the description box below. Now here I've opened Jupyter notebook. So what we'll do is we'll start with creating a new notebook. We'll click on Python 3. Okay, let's just rename it to NumPy 1. Okay, the first thing we need to do is we need to import NumPy. So if you have installed NumPy, you can import it like this, import NumPy. Okay, but most of the places you will see importing of NumPy like this, import NumPy as NP. So we can, so if you want to use any of the NumPy functions, we can just refer them by NP dot. Okay, let's run it, and yeah, first thing we need to do is how to create NumPy arrays. Okay, so let's say we have a list, we'll call it dummy list, and we have values of 1, 2, and 3. Okay. Now if I print this dummy list, we got 1, 2, and 3. Okay. Now to create a NumPy array, we'll write np dot array, and we'll pass our dummy list. Okay. So now see the difference. If you are printing a list, if you are just outputting a list, you'll get 1, 2, 3 like this. And if you are outputting your NumPy array, you are getting array. So it specifies that this is a NumPy array. So this is one array in or 1D array. Okay, we can also create two-dimensional arrays with like a matrix. So we'll write NumPy list 2D. They will just treat it like that. And seven, 8, and 9. Let's print NumPy as 2D. Okay. Now to create a 2D array from a 2D list, again the process is simple, np.array, and just pass on your list. Okay. Just let's print it also here. Yeah. Now same with 3D. I'll just show you one example of 3D. I won't go too deep into 3D lists. So what I'll do is I'll just copy this, copy it once more, and wrap everything in one other list. Let's do this. Okay. Now to create a 3D list, again we have function is same as np.array. I'll just pass on the dummy list 3D. All right. Now this is a very basic thing for creating arrays. We have a few functions also to create arrays. First function is np dot zeros. Okay, let's say we put 5 here. Okay, so it will create one array of zeros of length 5. Okay, same as if we do np dot ones, put 4, so it will create array of initial value as ones. If you do with zeros, your initial value would be 0 of all the elements, and inside the parameter is just the length of your array. Okay, now what we can do is we can also do this np dot zeros, and inside this, instead of passing just one value, we can pass a tuple, and we can just say 5 comma 3. Now what it does is it will create one matrix of all the zeros of 5 and 3. Okay, now if you want to create a 3D array, just add a third parameter. Okay, same as with ones. I'll just copy and paste. um, so we'll just pass a tuple here. We'll call it 4 comma 2. Okay, so 4 rows and 2 columns. Same will work with a 3D array. 4 2 2 6 8. Okay, the next function we have is arrange. It works similar to what range function what does in Python. For example, if you write it like this, so if you write it like just like this, okay. So what it will do is it will create an array starting from 0 till 9. It will go till 10, but it will not include 10. Right? Now what I can do is I can do it like this. So what it means is it will start from 1. It will go till 10 but not include 10. I mean, it will go till 10 minus 1. So we have from 1 to 9. Okay. The third variation of this is it accepts one more parameter, that is the difference, or let's call it the space between two consecutive elements. Okay. If I run this, see, we got 1 3 5 7 9. Now the 2 represents the difference between two consecutive numbers. Okay. So this, so with this, you are getting increasing numbers. So if you want decreasing numbers, what you can do is you can write it like, so you can start with higher number, then go to lower number, and the difference would be negative of 1. Okay, so you have from 10 to 0, but not include, it won't include 0. Okay, like this. If you want a difference of 2, or let's say if you want a difference of 0.5, okay, so 10, then 9.5, then 9, then 8.5, then 8, like this. Okay. Now we have one more function which is linspace, which works similar to arrange. Okay, how the difference is like this linspace. Okay, the difference between arrange and linspace is the third argument of arrange takes the difference between the two consecutive elements. But the linspace's third argument takes, if you, let's say if you give it 20. So now what it will do is it will create 20 numbers from 1 to 10. Okay, so it will get 20 numbers from 1 to 10. Let's do a simpler example. We'll start from 0 and we want 10 elements. Okay, so from, if you start from 0 and you go to 10, you'll get this. Okay, or if you had done 1, then it would have been a bit more easier. Yeah, like this. So linspace's second argument is 10, and sorry, arrange's second argument, we your values don't go till this ending position, but in linspace it does. Okay, so linspace, what it will do is it will start from here and it will end till here, and it will give you these many equally spaced numbers. These many equally spaced numbers. Okay, let's see one more example of linspace. Linspace will start from 11, go till let's say 40, and we want 80 numbers, or let's say 60 numbers. Okay, so it will divide. It will start from 11, go till 40, and it will have 60 numbers in between, including 11 and 60. Hope this is clear. Now we have few utility functions, like if you want to combine two arrays. Okay, let's say you have an array of one, 1, 2, 3, 4, and the second array is 5, 6, 7, 12, 7 and 8. Okay, now you want to concatenate these two. Okay, what I mean by concatenate is combine these two. You can do it like this: np dot concatenate a comma b. Okay, now there are other ways to do this also, and those methods are probably better than this one, but uh, this method is also there. Okay, now we have seen some functions. Now we'll see some attributes or some properties of a numpy array. Okay, let's let's use this, the 2D array which we created. Yeah. Okay, now if you want the shape of any array, so you can get that with array dot shape. Sorry, array underscore 2D. Okay, it's giving you 3 by 3, meaning this array has 3 rows and 3 columns. The first argument is rows, second argument is the number of columns. Okay, next is d type. So the d type property tells you what kind of values does this array has. So it has integer arrays. Now if we do this d type on here with this array, okay, it will give us float because these are floating numbers, right? And this was all integers, so that's why we have we're getting int 32. Okay. Now if you want the dimensions in your array, meaning, so this array is a one-dimensional array and this array is a two-dimensional array. To get the dimensions, you have property as array dot enddim. It will give us 1 because this array is one-dimensional array. Now if we do it with 2D array, we get 2 because that array is a two-dimensional array or 2D array. Okay. Next is, if you want to find out how many elements you have in your array, okay, that you can find out using size. So array 2D is of size 9 because it has 9 elements. Let's see, 3, 3, 6, 3, 9. Okay, same way, let's do it with this array. Sorry, its size, we got 60 because we have 60 space elements, right, from this linspace. So this is all about how to create arrays, what are basics of NumPy arrays. From the next In the next video, we'll look at what are basic operations like um, adding a new access, reshaping arrays, adding two arrays, subtracting two arrays, like those things. Okay, so that's it for this one, and we'll meet again on the next lecture. Thank you.